Hello everybody. I feel like this is the first one I've recorded in a while. I can determine if a function is even, odd, or neither by checking for symmetry and substituting negative x. So to determine if a function is even, odd, or neither, there are two methods. One is graphically, and to check it graphically, we're checking for symmetry. Even functions are symmetric to the y-axis, whereas odd functions are symmetric to the origin. And symmetric to the origin is the same thing as a rotation of 180. Algebraically, we're going to evaluate f of negative x, and if f of negative x equals f of x, it's even. Basically, that means if it's the same, it's even. If everything is opposite, then it's odd. We'll talk about what all that means. And in order to remember all this, we have a song. This is a very interesting song. It's a rap. It's fast, so you got to really work at seeing if you can handle this, which also at the same time gets to even memorize it even more. So let's find my Math Schlansky playlists, Common Core Algebra 2 songs, and even odd functions. The words are beneath the video. Yeah, so let's start with graphically. Even is symmetric to the y-axis. Odd is symmetric to the origin. So this is even and odd functions in your packet. I actually just recently changed this, so if this is 2020 and you're looking at this right now, it might not match what's in your physical packet, but I did update this lesson, so just be aware of that. So I want to check for symmetry. Is this symmetric to the y-axis? Is it symmetric to the origin, or neither? So let's start by checking to see if it's symmetric to the y-axis. Does the y-axis cut this thing exactly in half? If I flip it over the y-axis, will it land on itself? That's kind of something you talked about in geometry. And yes, the y-axis is a line of symmetry. It is cutting this in half. So it's even because it's symmetric to the y-axis. Number two, is it even, odd, or neither? So, is it symmetric to the y-axis? Is that a reflection of itself over the y-axis? No. If it was, then this piece would look like that. That's what it would look like if it was symmetric to the y-axis. So no, it's not symmetric to the y-axis. Is it symmetric to the origin? So basically what that means is if I take a point and I count to the origin and I do the same thing on the other side, will it land on itself? Yes. Now, that's a little tricky. The easier way to do it is a rotation of 180. So if I take this thing and I turn it upside down, do I get the exact same thing that I started with? Is that exactly the same as the original if it's upside down? Yes. Therefore, it is odd because it's symmetric to the origin. I feel like I should be typing this. I'll start typing it. Number three, Is this symmetric to the y-axis? Is the y-axis cutting it exactly in half? No. If it was, then this piece would look like that. So no, it is not symmetric to the y-axis. Is it symmetric to the origin? Well, if I turn it upside down, will I see the exact same thing in the exact same spot? Not even close. One's upside down, one's on the right, one's on the left. So it's neither. Writing neither is fine. I mean, if you want a full explanation, neither. It's not even because it's not symmetric to the y-axis. It's not odd because it's not symmetric to the origin. The explanation more comes into play if you're explaining why it's even or odd, but it's neither because it's not symmetric to the y-axis. It's not symmetric to the origin. 4. Even, odd, or neither. Well, let's start by checking for even. Even f of x equals f of negative x. It's symmetric to the y-axis. Is this thing symmetric to the y-axis? No. If it was, then this piece would look something like that. It is not symmetric to the y-axis. Is it symmetric to the origin? The easiest way to determine that is to turn it upside down. Do I see the exact same thing if I turn it upside down? Yes. So, odd because it's symmetric to the origin. And also another way of doing it, again, a reflection in the origin means if I take this point and I count 2, 1, 2, 3, 2, 1, 2, 3, if I count through the origin, it will land on itself. I want you to take a few minutes right now. I want you to get, why don't you try 5, 6, 7, 8, 9? So why don't you please pause the video, try 5 through 9, and then unpause. Okay. Now that you tried 5 through 9 on your own, if you did not try 5 through 9 on your own yet, then pause. Now that you try 5 through 9 on your own, let's go over it together. To determine if it's even, it would be symmetric to the y-axis. Is this symmetric to the y-axis? Almost, but no. If it was symmetric to the y-axis, this piece would look more like that. It goes much lower on the left-hand side, so it's not symmetric to the y-axis. Is it symmetric to the origin? If you're not sure, you can turn it upside down. Is it exactly the same? Not even close. So this one would be neither. Because it's not symmetric to the y-axis, it's not symmetric to the origin. 6. Let's check to see if it's even. Is it symmetric to the y-axis? Yes. Okay, that y-axis is cutting exactly in half. If I flip it over the y-axis, it will land on itself. So it is even because it's symmetric to the y-axis. 7. Let's check for even. Let's check the y-axis. Does the y-axis cut it exactly in half? Yes. So this one is also even. Even because it's symmetric to the y-axis. 8. Let's check for even. Is the y-axis cutting this thing exactly in half? Close, but no. If it was, then this piece would look something like that. It doesn't. Is it symmetric to the origin? Well, the easiest way to do that, I mean, one way, again, is to kind of count and see if it lands on itself. The other way, easier way, is to turn it upside down. And you're physically turning your paper and turning it upside down, or turning your phone or laptop or whatever you're doing and turning it upside down. Are those exactly the same? Not even close. So this would be neither. We haven't seen an odd in a while. Hopefully number 9 will be an odd. Even f of x equals f of negative x. It's symmetric to the y-axis. Is the y-axis cutting this thing in half? No. If it was, then this piece would look like that. So it is not symmetric to the y-axis. Odd f of negative x equals negative f of x, symmetric to the origin. Symmetric to the origin is the same thing as a rotation of 180. If I turn it upside down, does it look exactly the same as the original? Yes. So it is odd because it's symmetric to the origin. That's it. So for even and odd functions, even are symmetric to the y-axis, odd are symmetric to the origin, and if it's neither of those, then it's neither. Algebraically. So to determine if it's even or odd algebraically, my first step is to substitute negative x in for x. I'm sorry, before we talk about this, let's talk about this. Negative to an even power, negative to an odd power. If I raise a negative number to an even power, think of it like negative 2 squared. Is the result positive or negative? Well, the result would be positive because negative 2 times negative 2 is positive 4. So a negative to an even power is positive. Negative to an odd power, for example, negative 2 to the third, that would be negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4, times negative 2 is negative 8. If you raise a negative to an odd power, the result is going to always be negative. So that's very important for this right here. Negative to an even power is going to always be positive. Negative to an odd power is going to always be negative. So I start by substituting negative x in for x. Negative to an even power is positive. So this whole thing becomes positive x to the fourth. The negative out front stays, and I end up with this. So basically, if the whole thing is positive, the sign in front stays. If the whole thing is negative, the sign in front changes. Now, I compare this to the original. If it's exactly the same, it's even. If every sign is different, it's odd. If it's a mix, it's neither. So is this exactly the same as the original? Yes. So it's even. Now the mathematical way of saying that is f of x equals f of negative x. That means when I substitute negative x in for f, I get the exact same thing as the original. So that's what the song says, even f of x equals f of negative x. Also, I could always go to my calculator. I could go to y equals. I can do negative x to the fourth plus 4. I can look at the graph. Is that symmetric to the y-axis? Yes. Therefore, it's even. But if it says to do it algebraically, you have to do it by substituting negative x and showing it's the same as the original. To determine if a function is even, odd, or neither, algebraically, I start by substituting negative x in for x. Negative to an odd power is negative, which means this whole thing becomes negative. Negative times a negative is a positive, so this becomes plus 2x. So again, here, this whole thing became negative because negative to an odd power is negative. So this whole term, the sign changed. And then the same type of thing happened. I compare this to the original. If they're exactly the same, it's even. Are they exactly the same? No. If every sign is different, is odd. Is every sign different? Yes. Positive became negative, minus became plus. What that means, if every sign is different, that means that it's odd. Because, well, mathematically, how do I say that? Odd of negative x equals negative f of x. What this is saying is when I substituted negative x into the function, the entire function got negated. So that's how you determine if a function is even, odd, or neither. Substitute negative x, compare it to the original. If everything is the same, then it's even. And mathematically, how I express that is f of x equals f of negative x. If everything is opposite, it's odd. The way to express that is f of negative x equals negative f of x. If you wrote odd because all the signs changed, that should be good enough. All right. I wouldn't take off points on a test for that, but mathematically, this is how you'd express it. 18. Substitute negative x. Negative to an odd power is negative. So this whole thing becomes negative 4x to the third. Minus 6, there's nothing to substitute in, so that doesn't change. Compare it to the original. If it's exactly the same, it's even. Is it exactly the same? No. This one has a positive 4x, this one has a negative 4x. Is every sign different? No. This has a minus 6, and this also has a minus 6. So because it's not exactly the same, and because everything isn't different, we say that it is neither. And, I mean, as far as the explanation, they probably wouldn't ask you for an explanation of why it's neither, but if you did, because f of x is not equal to f of negative x, and f of negative x is not equal to negative f of x. All right. Timeout. Okay, so I just realized that the intention of this was to do it graphically. So cool, you got a little head start into doing this algebraically. I'm not going to re-record anything. But if I want to do this graphically, and they give you an equation, just go to your calculator. Go to your calculator, type in alpha y equals, enter 1/2 x to the 5th minus 2x. Look at the graph. Is it symmetric to the y-axis? No. Is it symmetric to the origin? Well, you can kind of turn your calculator upside down, but what I can do to more clearly show you is kind of like snip that. If I turn it upside down, is it exactly the same as the original? Yes. So if I'm doing this graphically, then I would say odd because it's symmetric to the origin. So I gave you a little head start into the algebraically, but I didn't realize that I put these on the worksheet where these are graphically still. The next page is algebraically. So number 19, if I want to do this graphically, I'm going to go to my calculator. I'm going to type it in. Y equals. So to type in the absolute value bars, there's a couple different ways to do it. Alpha, window, 1. is the way that I like to do it. I'm going to type in the X. I'm going to move my cursor out of the absolute value bars. I hit graph. I look at that. Is it symmetric to the y-axis? Yes. So it is even because it's symmetric to the y-axis. So graphically, if they give you an equation, you can just type it into your calculator and look to see if it's symmetric to the y-axis or symmetric to the origin. And again, symmetric to the origin, meaning a rotation of 180. So I obviously just gave you a nice head start on the algebraic. So let's kind of skip ahead. Let's take a look at number 28. And again, if I want to determine if this is even, odd, or neither, I'm going to substitute negative x in for x. And now negative x to the third. A negative to an odd power is negative, so this whole thing becomes negative. A negative to an odd power is negative, so if this whole thing is negative, then this minus sign becomes plus. Because when I subtract a negative, the sign changes. So essentially, if it's negative, the sign in front changes. If it's positive, the sign in front stays the same. I compare this to the original. If it's exactly the same, it's even. Is it exactly the same? No. If all the signs are opposite, it's odd. Are all the signs opposite? Well, a positive became a negative. A minus became a plus. So yes. So it's odd because f of negative x equals negative f of x. This means when I sub in negative x, all the signs of f of x changed. I want you to try, let's skip ahead here. I want you to try 32, 33, and 34 on your own. So please pause, try 32, 33, and 34 on your own, and when you're done, unpause. Now you completed 32, 33, and 34. Let's go over them. Your first step is to substitute negative x in for x. When I raise a negative to an odd power, the result is negative. So this becomes negative x to the 7th. Negative to an odd power is negative. So this becomes, instead of plus, minus 2x to the 5th. And this whole thing is negative. So this negative becomes plus 9x. If you're raising to an odd power, the whole term is negative, which means the sign in front changes. Compare this to the original. Are the signs exactly the same? No. Are all the signs different? Yes. So it's odd because f of negative x equals negative f of x. That means when I sub in negative x, all the signs change. 33. To determine if a function's even, odd, or neither, I sub in negative x. Negative to an even power is positive, which means the sign in front stays. Negative to an even power is positive, which means the sign in front stays. Negative to an odd power is negative, which means the sign in front changes. Compare it to the original. Is it exactly the same? No, because that's a negative and that's a positive. Is everything different? No, because that's positive and that's positive, so it's neither. If it's a mix of the same and different, it's neither. If they're all the same, it's even. If everything is different, it's positive. So finally, the last one we're going to go over, sub in negative x. Negative to an even power is positive. Negative to an even power is positive, so the sign stays. There's nothing to sub in for the 7. Compare it to the original. Is everything the same? Yes. So it's even because even f of x equals f of negative x. And it's also symmetric to the y-axis. If I were to catch this into y equals, I can look at it and see that it's symmetric to the y-axis. Now, so to sum up, for even and odd functions, even functions, algebraically, when you sub in negative x, it's equal to the original. Odd, when you sub in negative x, everything is opposite from the original. Graphically, even functions are symmetric to the y-axis. The y-axis cuts it in half. Odd functions, the graph is symmetric to the origin, which means when you turn it upside down, you see the same thing back. Now I'm going to show you a shortcut which will work sometimes, but not every time. It will work on polynomial functions. So here's how it works. If all, I guess I should type it. This only works for polynomial functions. If all of the exponents are even, it's even. If all of the exponents are odd, it's odd. If it's a combination of even and odd, it's neither. Now the twists. Constant terms are even. And where's my star? X is x to the first, which is so constant terms are even. I'll talk what that means in a moment. So if all the exponents are even, it's even. If all the exponents are odd, it's odd. If it's a combination, it's neither. And then you have to understand that if you use this shortcut, constant terms are always even. I'll explain why in a moment. And if it's just a regular x, it's x to the first, which is odd. So in this one, the only exponent is even, therefore it's even. In this one, the only exponent is odd, therefore it's odd. In this one, I have x to the third and x to the first. They're both odd, so it's odd. This one, x to the 8th and x to the 2nd, they're both even, so it's even. Now, there's no exponent for this because there's no x. Because there's no exponent, technically, this is x to the 0 power. Because x to the 0 power is 1, which makes this even, which makes this even, which makes this even. So a constant term, a term without an x, technically has an x to the 0, which means it's an even term. Even though 3 is an odd number, it doesn't matter. It matters about what the exponent is. If you have a constant term, the exponent is even. So this one, odd, this technically has an x to the 0. That's even. Odd and even is neither. So that trick will work for polynomial functions. It won't work for, something like this, for an absolute value function. It won't work for something like this, a rational function. But it's just a little shortcut that you may be able to use sometimes. Will you get full credit for that? Probably not. But again, I like to empower you with all the information. So this was kind of a long lesson, a very long lesson. There's a lot of stuff that's important to know about even and odd functions, how to do it both graphically and algebraically. And again, to sum up what you need to know about even and odd functions. Even f of x equals f of negative x. It's the metric to the y-axis.
Negative, symmetrical, negative, that's symmetric to the origin. Now, symmetrical, negative, that's symmetric to the y-axis. Negative, symmetrical, negative, that's symmetric to the origin.
Oh yeah. Have a great day. Your classwork/homework is to finish. Bye.